This is episode number 1 with ex-chemical engineer and now data science wizard, Ruben Kogel. Welcome to the Super Data Science Podcast. My name is Kirill Eremenko, data science coach and lifestyle entrepreneur. And each week we bring you inspiring people and ideas to help you build your successful career in data science. Thanks for being here today, and now let's make the complex simple. Hello and welcome to the very first episode of the Super Data Science Podcast. I can't explain how excited I am to finally get this show off the ground. I've had this idea for literally months now, and finally today we're kicking things off. And what is this show all going to be about? This show is going to be about inviting the most aspiring data scientists in the world and talking to them about what they do, what their background is, what they've learned in their path on the data science journey, and what they can share, what insights, what tools, what methodologies they can share with us and what we can learn together from them. So I'm very excited that you're here from the very start, that you're listening to this very first episode. Thank you so much for being part of this journey. I'm sure that together we're going to learn a lot. And I'm very glad that this first episode we kicked off on a very high note. I spoke with Ruben Kogel, who's a data scientist at Udemy. So if you're not familiar with Udemy, it's the biggest online education platform in the world. Currently, there are over 11 million students learning through Udemy. So if you haven't checked them out, definitely check them out. There are courses on basically anything that you could potentially imagine. And personally, I'm an instructor on Udemy as well. I have over 20 courses there and near 50,000 students. So it's a great learning platform. And Ruben Kogel is one of the head data scientists in one of the divisions in Udemy, so the division that works with content and content marketing. And Ruben shared some very powerful insights about what he does on a daily basis at Udemy, and moreover, how he transferred his chemical engineering background into a data science skill set, how he went and took an MBA and specifically selected the subjects in such a way that he was able to learn more about data science and get into that field, so make the jump from chemical engineering into data science through his MBA. He also talked about communicating insights and how important it is in the data science role. Also, we discussed lots of other topics such as identifying problems when you're a data scientist, how important that is, how to combine data science and product strategy. That is something that Ruben does on a daily basis, and you'll learn more about that. And so that's a very powerful skill to have, especially if you're working in the startup area or the startup space in companies predominantly in the Silicon Valley or any other kind of location where you've got this startup culture. Then we also spoke about managing a team of data scientists. So Ruben has got quite some experience around that, and he gave some tips. So if you're a manager in data science or in that analytics space, you can pick up some good tips from there. Also, we talked about managing the inflow of requests, and that is valuable to any data scientist, how to manage the inflow of requests. And Ruben gave us an example of his approach with the Trello board. We talked about the importance of mentors in data science. And of course, we talked about lots of different analytics tools. We talked about PostgreSQL and a add-on which I didn't know about personally. We talked about Wagon. We talked about R versus Python. So the million-dollar question, which one is better, which one is more preferable. And we talked about many, many other things in this podcast, so I'm sure you're going to enjoy it. And we even touched on self-serve analytics, so a growing space of the field of data science. So without further ado, I bring to you Ruben Kogel of Udemy.com, and enjoy. Hey guys, welcome to the podcast. I've got Ruben Kogel here from Udemy. Super excited about this very first episode. Ruben, welcome. How are you going?
Thank you. Thanks for having me over. I'm doing great.
Awesome. It's great to hear you. And for those of you who don't know, I met Ruben for the first time when I was in San Francisco a couple of months ago for the first Udemy Live conference. And it was pretty exciting. And he ran some great presentations. But just so that everybody gets up to speed, Ruben, tell us a bit about what do you do? What's your title in the company, and what exactly do you do in your role?
Yeah, sure. So I'm the senior manager of analytics and strategy at Udemy. And basically what I do is I help the content team, which is the team that looks at the courses and the content in Udemy, figure out what is in the catalog, what's the selection of courses, what's the quality of courses, how can we improve our catalog to make students happier. In practice, a lot of my work has to do with, are we measuring the right things? Are we measuring student satisfaction? Is that data available so that the people who are in charge of bringing in courses know which courses are good? And how do we measure also like the selection of courses so that we can slowly build a better and better catalog for our students?
Awesome. That's really cool. So you apply data science techniques in order to measure those kind of metrics. Is that correct?
Totally. I mean, data science comes in different parts of my job. So there's like the more basic part, which is instrumentation. So at the start of like any data endeavors, you want to make sure you're measuring the right things and that data is available. So for me, it means that are we measuring student satisfaction correctly? And is that data available so that people, the company can access it and make decisions on it? There's another level in which I use data sciences. Then there are like, broader questions that come in. And so that's what I call like ad hoc analysis. And so someone might ask me, what happens if we remove some of the low quality courses from the platform? Can we predict what will be the impact on both satisfaction and revenue? So that's kind of a question where you need to not only structure the problem, but also come up with some predictions and use some techniques to like evaluate what would be the impact with maybe some confidence intervals. And there's like another type of question that can be, well, we know that there's a variety of courses and they all have different quality scores. And we want to know what about those courses is driving those quality scores. And, is it that the audio quality, the video quality, is it the instructor delivery? So in that case, data science comes into play, both in terms of structuring the problem, but also running some sort of statistical analysis to extract the importance of the different variables and come back with an answer saying like, well, I think, this variable is the most important. And, if you move that variable by like 1%, that will have an impact on student ratings by that much. So that's another example.
Oh, that's really cool. So kind of two main types. One is metrics of existing metrics and how you can tweak them to improve the experience of students. But another one is where the first one you mentioned, where you're doing kind of behavioral analytics and predictive behavioral analytics to see how you can change things so that the future experience is going to be better. So that's pretty cool in my view. And it's great that you get to do both parts in your role as a data scientist at Udemy.
Yeah, it's really, really cool. Actually, what I really like about my role here is it's really at the interface between data science and sort of like strategy product, because I get to work on data sets and I get to do a lot of data analysis. But at the end of the day, the people I talk to are VP of content or director of course acquisition, and people who are like they're like in the weeds, they are doing the business, and I get to give them recommendation. I get to influence their decisions or influence the product with data. So it's this really cool interface between data and business.
Definitely. And that's what I've also found, that the most interesting and the most impactful roles and careers happen on the verge of two fields. Whether if it's, for example, you could take like physics and chemistry or biology and chemistry, but that's very exaggerated examples. But even in data science, one thing is to just do the analytics, and another whole thing is to do the analytics and at the same time convey the findings and work with those people that use analytics. And just on that as well, how do you find conveying such complicated analytics to your stakeholders, that, like you said, the VP of content? Is there any certain approaches that you use or any tips you can give to our listeners on communicating these findings to senior stakeholders in the company?
I'll start by saying that any analysis that you do is useless and irrelevant if you're not able to communicate the findings to people. So communication is a huge part of like being a successful data scientist. But there's like two sort of like rules that I try to use when I communicate things. One is translate technical concepts into something that people can understand. You don't necessarily talk about confidence intervals. You can talk about, your confidence in the data, or you can say like, well, I think, the prediction or like the predicted revenue will be between those two bounds. You don't have to say 95% confidence, because that doesn't add a lot of value. But at the same time, you also want to convey precision in your communication and make sure that you don't throw in an answer like, yeah, I think we should do A because that. I think it's important that you convey like, well, I looked at the data, and if we do A, we can lift revenue by this amount, and maybe there's a little bit of an interval in terms of like what I think we can lift revenue, but this is what the analysis is doing. So it's like this like balance between being precise and showing that you've done your homework and showing that this is like rooted in data, but at the same time translating it into layman words and stripping away any technicalities that don't add a lot of value to your message.
Totally agree. I've got a classic example on that. How often stakeholders, especially senior stakeholders, are very skeptical about sample sizes, for instance, right? So if you run some analysis on a sample size of 157 or 300, they might be prone to say, actually, we want a sample size of 10,000. But you, as a data scientist, know that that sample size that you ran is significant, statistically significant. So it is important to convey these findings in a way that when you are confident in them yourself, you don't have to go into all of that detail to explain exactly the methodology behind it, but actually just convey the confidence in the way you present, the way you position your analysis. So totally agree on that one. Interesting thing that I would like to ask you, and probably a lot of our listeners would be curious about, is can you tell us about your background? So how did you come into being a data scientist and progress in, of course, you progressed further in your career and now you're the head of analytics in that department. But originally, how did you get into data science? Because this is quite a new field and back in the day, it wasn't being taught at university. So how did you get here and what were the steps?
It's a very interesting question because I had a very meandering path. I didn't start at all in data. My background was in applied physics, and then I switched to material science, and I was a chemical engineer for many, many years. I was dealing with data, but not the type of analysis that you do when you're a data scientist. It was a lot rougher and not as sophisticated. And what happened is I was looking to transition to something different, and I went to business school, and you don't typically think of business school as a place where you learn data science, but I had this opportunity to take a few statistics courses and one like data mining course, and I sort of like fell in love with the field. And like the more I learned about it, and the more I was really intrigued. And so I really learned the theory in business school, and then I had this opportunity to come work to Udemy and apply some of my knowledge. That's how I started my career. So it is pretty recent, and it was also like a pretty stark contrast from what I was doing before.
Definitely, that's a great jump. And like you say, one wouldn't expect that you would learn all the necessary data skills at business school, but I guess you picked the right subjects, and that's a great testament to how lucrative the data science field is. And tell us skills that you developed as a chemical engineer or working in that field. Is there any way that you leverage them currently? Because data scientists come from all different areas, whether it's some people come from acting classes, some people can come from economics or finance, but coming from a chemistry background, is there any skills or any particular mindsets that you can share with us that you leverage in your current work as a data scientist?
Surprisingly, it's not the data skills that I leverage from my chemical engineering background. It's more the problem solving and communication skills. I think any engineering work has a heavy component of troubleshooting and problem solving. And so I was doing a lot of that in my job, and it really forced me to come up with like a very systematic approach to breaking down a problem, coming up with some hypotheses, and then testing those hypotheses and be extremely systematic and organized about and structured about my thinking. So I definitely learned that from my engineering background. The other thing that I learned is, as I mentioned, communication skills. As an engineer, especially like in my position, I was doing a lot of like account management. I had also to translate a lot of very complex technical experiments and results into something that the business people could understand. And the ability to summarize complex concepts and notions into a few, whether it's a slide or whether it's an email, and in a few paragraphs that really sum up the insights is very important. And that's something that I learned in my engineering job. And it's something that has served me also in my current career.
That's really cool. And it's definitely the problem solving skills. That's a very valuable thing to have when you're dealing with data science challenges. From what you're saying, I gather that your communication skills have played a very significant role in terms of your success. How would you recommend? Because my thinking is that a lot of the times when people are starting out into the field of data science, now it's getting more and more popular, sometimes they can get pigeonholed into certain roles where they are performing some analytics, but they don't have that exposure to go and share their insights with stakeholders. They're just performing certain SQL queries or certain analytical procedures, but they don't actually have a chance to communicate insights. So what would your suggestion be, like off the top of your head, for people, for our listeners who might be in that situation, to somehow start developing those communication skills nevertheless?
Yeah, I think there are two ways you can do that. One is even in your day-to-day interaction with customers. I always think of like analytics or data science as you have customers inside the company, whether they are technical customers or business customers. People ask you questions or ask you to perform an analysis and you have to give them an answer. So whenever you interact with your customers, you can always like go the extra mile and structure your answer not just as the output of of a regression analysis or as a SQL query, but like you could try and explain like why you think this is the right thing to do, what that means in practice, what would be your recommendation. So always like push the results past just the technical output, but and package it in a way that shows that you've thought about the implications and the meaning of your analysis. So that's one thing. The second thing is I also like always recommend people, and that's true of people who work for me or people who might work in other positions, that whenever you are given a problem, it's always a good practice to try and dig into exactly what problem the person is trying to solve. Because oftentimes someone will come and say like, hey, can you pull this data? Or hey, can you build a dashboard for that? Or can you do an analysis around this? But like really, they're trying to solve a problem and they may not tell you exactly what problem they're trying to solve. And so if you engage with that person, that customer, and try to really get to the bottom of what problem they're trying to solve, all of a sudden you're starting a conversation around, yeah, what are they trying to solve and what can you bring besides just the output of an analysis, and how can you help them frame the problem? And so all of a sudden you're engaged in communication, you're engaged into like expressing a problem, breaking it down into some more elemental data problem, and coming back with a solution that addresses really the underlying problem. So that's one way in which you can like push the boundaries of your current job and really expand into delivering like more value that is built upon this communication and build upon this like understanding of what's the underlying problem. So that's number one. I think number two also is, generally speaking, analysts have like this unique ability to look into the data, come up with some insights that no one else in the organization has. And so as an analyst, you also have the opportunity to maybe start addressing problems that other people may have also, or some people may not have thought about. And you can create value by being a little proactive about what you think we should be looking into, what you think would be a useful analysis with some useful insights for other teams. So there's also that opportunity because no one else can really look into the data. You're the only person who has access to the data and also can bring out the insights.
Beautiful, love it. Especially the what is exactly your problem. That is one of the best skills to have as a data scientist, to help people identify their problems, because they often come to just data and instead of actually identifying problem. And regardless of what level you're at as a data scientist or data analyst, eventually that skill is the one that will push you forward. And combining it with what you said about the proactive approach, that's where you become the doctor for the organization, and you walk around and you measure what's going wrong and how you can help fix it. So yeah, definitely agree with those two. Those are some very powerful skills to have. You mentioned that you're in charge of a few people. Can you tell us a bit more about that? How many people are you in charge of, and how do you find it managing a team of analysts or data scientists? What are the challenges that you face on a day-to-day basis?
Right now, my team is down to one person. So at the heyday, we had a bigger team, but things move quite quickly in Silicon Valley. So I have one person reporting and hiring at least one person for the moment. The thing that I find the most challenging in terms of like managing and growing analysts or data scientists is oftentimes there's this tension between trying to please your internal customers and trying to make as many people happy as possible in a shortest amount of time, and trying to build long-term value and work on like longer term projects. The way I think of like a data scientist is like you're at the end of the chain. There's a lot of people in the organization, they manage projects, they ask other people to do things, and and eventually when you put all the contributions together, you come up with a product. But when you're in data science, you don't ask other people to do things, or it's very rare. Like usually you're the last person that they ask. And so there's a lot of people coming to you and you end up having a ton of requests, and managing the inflow of requests and managing the different things they're working on can be very challenging. And oftentimes, like new analysts, they tend to gravitate towards maybe like the more short-term projects, the things that the last person asked them to do is like, oh yeah, I'll do it right away. And to the detriment of working on the bigger, longer term and more impactful projects. So that's one of the challenge.
That's definitely true. And that kind of flows into the art of saying no to people who come to you as a data scientist, especially when you're running a department and when you have a few successes, you'll find more and more of the other departments from the company and people and stakeholders coming to you with requests. So how do you say no? How do you tell people that, hey, your project's really cool and I'd love to work on it, but at the same time, I've got other commitments. What are your tips around that?
You don't really say no. There are the two things you do. One is you make it very clear what your priorities are. And one of the tools that we use here at Udemy is a Trello board. So Trello is a productivity tool that it's like virtual post-its. Essentially, it enables you to have a public board of what you're working on, what is the stage of the different projects, what are the stakeholders of different projects. And if someone asks you to do analysis, you can say, okay, no problem. Can you just put a card on my board? And then very quickly they realize that their card is, one of 50 other cards. And now there's actually a prioritization process for the team to start working on it. So that's one way to work on it. The second part is like, really what you want to do is you don't want to work on each individual request and solve them. What you want to build is like scalable infrastructure. You want to build scalable analytics. What that means is instead of answering the same questions over and over again, or instead of like pulling data for everybody in the company, you build self-serving tools. You build tables, dashboards, web UIs that enable people to access the data that they need so that they don't ask you to do the data pool or the data analysis anymore. And so you can free up some of your bandwidth to work on the more interesting projects.
Awesome. Love it. The self-serve analytics has becoming a more and more popular concept in the world of data science, specifically for that reason, to free up the data scientist and to empower the end user to do their own analytics. And so just on that, what kind of tools do you use in Udemy, if you can disclose this, for the self-serve analytics side of things?
The basis of the self-serve analytics is creating a set of summary tables that have all the relevant information that cover 90% of the use case. What I mean by that is, for example, typical questions that come at Udemy is like, oh, do you have a list of courses that have been published this month? Or what is the total revenue of courses that were published last month? Or can you look up a particular instructor and see how many enrollments or reviews she has in her courses? So there's like a limited set of questions that come over and over again. And instead of like building queries or like every time to extract that information, you just build one or two tables that have all that information summarized. People can access the data directly by either querying the table with SQL or by looking it up with a dashboard. So in practice, what we do is we have all our data information flow into Redshift cluster. So Redshift is a service by Amazon, and that lets you build tables on top of like raw tables. So we have what we call those summary tables that are built upon the raw. Or they can power dashboards. We use Chartio, and they can use the Chartio UI interface to extract whatever information they need.
Okay, so Redshift and Chartio. Yep, those are the two tools. Very nice. And so you store Amazon use AWS for storage of data. Is that correct?
Mm-hmm.
And how do you find that? Has that been a recent transition for your organization, or that's been always the case?
No, it's been a transition about a year and a half ago. We used to have only our traditional MySQL owned server, and then we started exploring Redshift, AWS Redshift, and we saw that it was much more powerful in terms of doing analytics. Because like typical MySQL database is optimized for writing, but not necessarily for creating new tables or querying new tables. Redshift is optimized for doing a lot of joins, a lot of analysis, and reading data. So we've been using Redshift for like the last year and a half, and we've been scaling the size of our cluster as our data grows and as our analytics team grows, and it's been serving us pretty well, actually.
I've heard a lot of comments about that on AWS you can scale with your needs, and that's one of the biggest advantages of AWS, that as your organization grows, as you need more capacity and processing power, then you scale that. You don't have to purchase that in advance, and also they're month to month or other type of plans. They're very convenient. Usually the only setback that organizations have, and maybe you can comment on this as well, is organizations that deal with customer data, with client-facing data, such as Udemy, they would have certain regulatory maybe certain regulatory issues with outsourcing the storage of their data to the cloud or to external systems like the AWS. Did you face any of that when you were making the transition?
Not really, in the sense that the data is still secure. And at least in the United States, the only data that is being heavily regulated is health data. So if you have a startup that does health, then there's regulations that can make it more difficult to work with the cloud, or you have to work with certified vendors that can really handle it's called HIPAA, the regulation about how you handle health data. For the rest, AWS serve like a very large range of startups, and they all have sensitive data, but they are set up to handle your sensitive data correctly. So there is not too much concerns around that. The only thing is that sometimes you want data to be used for web apps, in which case reading from Redshift is not the best way to populate field in your website or web app. And so you might need a second repository of data that is easier and faster to read than Redshift, which is based on columnar storage.
So we've slowly started delving into the tool. We've moved on from management tools like Trello, which I found pretty interesting, how you get somebody to post it in Trello on your board, and then they realize that, their project is going to be prioritized at some point and might not be done very quickly. And then we moved on to Redshift. So what are some of the other tools that you use on a day-to-day basis in your analytics role?
The two technology that I use, all the time is SQL, or for that case, like PostgreSQL, which is the basis for Redshift, and R. So I do pretty much all of my analysis in R. Basically, that's the language that I learn, and I'm very familiar with it. Some other people at Udemy use Python. It really varies. But I think one of the two they're very convenient and flexible, and those are the tools of the data scientist nowadays. Either Python or R. They have like the packages installed. It's open source. It grows as a very active community. So those are typical for data analysis. In terms of like the tool that I use to actually do my SQL, there's like a really neat company called Wagon. They still have a beta product, but they right now have the best SQL editor, especially for PostgreSQL. It's really neat because you can organize your queries into different folders. Everything is always saved on the cloud, so nothing is lost. And it's very there's a neat interface, and it's very easy to use.
Awesome. So that was a Wagon?
Wagon, yeah.
How do you spell that?
Wagon.
Beautiful. So I haven't heard of that one before. Something to definitely check out. And very interesting how your organization has a split between R and Python. I guess in the startup world, it's more common, but in the more larger organizations that have existed for a while, that have a lot of legacy behind them, usually analysts don't have that luxury of being able to choose between the two. Definitely R is something that a lot of our listeners are interested in. Could you maybe share a couple of packages or a couple of techniques that you most commonly use when you're coding in R?
Yeah, totally. So I'm going to probably disappoint you and your listeners. I don't use like a lot of different packages and advanced techniques. I tend to stick to like basic R. In fact, I don't even run like RStudio. I just use like base R. I don't use ggplot2. I just use like the base R graphics. I think part of the reason is I don't see R as a way to produce extremely sophisticated reports or analysis. I use R mostly to extract the information that I need and run like the basic analysis. So the typical thing that I would do in R is I'll just import a CSV file, read it, do a little bit of cleaning. Although I usually prefer to do my cleaning in SQL because I don't think you should be doing the cleaning in R. I think really the cleaning should occur upstream, and you only launch R to do some data exploration, create some graphs and do some statistical analysis. So typically I would run regression analysis. I use GLMNet to do lasso regression. I use random forest a lot also to build models or understand the relative importance of different features into a model. So that's kind of like my usage of R.
Wonderful. I totally agree with that. R is definitely a very powerful tool, and every analyst, every data scientist has the right to use it in the way they prefer. And you're kind of using R in a very lean approach, and that can be very powerful as well. The $1,000,000 question would be R versus Python. What are your thoughts, and why did you end up picking R?
My answer might disappoint you again. I never really chose between the two. I started with R, and it fits all my needs. I spoke with a couple of people who use Python, and I quickly realized that for the type of analysis that I was doing, which is, offline analysis, building offline model, trying to understand the drivers of a particular metric, Python would be more complex and would not add a lot of value. What I mean by that is in my day-to-day job, I don't build actual, data products. I don't try to deploy a predictive model onto our infrastructure, and therefore I don't need it to be in Python. all I do is I download some data, generally from Redshift, and I try to build some model to understand what's driving this metric up or down. And for this type of use case, from what I read, R is the simplest and more direct way of analyzing the data. And it's also like the language that I know.
Beautiful. Definitely. That is also the case in many situations when you start with one and then you just keep going with that one. If it suits your needs, then what's the point of changing? Totally appreciate that. All right, so that's really cool that we went into some detail on the tools you use and some techniques. I love that part of the conversation. Let's move on to a bit of more some of the more softer stuff. For instance, I can see that you've made this transition to data science from chemistry, and you've never looked back. You're like powering through it and progressing in your own career, growing other data scientists on your team and acting as a mentor. But along the way, did you have any influence that helped you become and persevere in this data science career, and maybe some mentors that you might have had, or hobbies, or some life-changing events, or even some articles or something that has really influenced you and helped you along this career path as a data scientist?
There was a big learning curve for me when I joined, because I had never exercised as a data scientist. And in fact, I didn't really have a mentor at Udemy. So I had to figure out a lot of things by myself or ask people outside. And so in general, I really encourage people to seek out mentors. In my case, I have a good friend of mine who had a bit of a head start on me. He started doing data science 4 or 5 years before me. He is someone who has strong opinions, but also is very thoughtful about the different approaches and the choice that he was making. And I often, had conversation with him, or we had like regular coffee where we exchange on technologies and techniques. I found this interaction with him very helpful. I went to different conferences, although I would say like not every conference is that helpful. The one that I really liked was the Airbnb in San Francisco. They put a conference called Open Air, which I really appreciated. And I also followed some blogs and newsletter. There's a newsletter that I really like called datascienceweekly.org. And it's a collection of interesting articles, about 10 to 12 interesting articles every week. I don't read all of them. I just pick the one that seems interesting. And if I pass the first paragraph and it's really interesting, then it's a full read. And slowly I build a catalog of tips, thoughts that I think very useful. And in particular, I can't remember if it was through this newsletter or maybe through some like LinkedIn online. I found someone posting an old article from Leo Breiman, the guy who created the random forest algorithm. It's an article that he published in 2001, which really resonated with me. And so I would really encourage anyone who's considering data science, who's starting in data science, or even who's like more advanced in their career to read this article, because for me, it really has expressed exactly the way I feel about the tension between statistics and machine learning, and the tension I feel between building explanatory models and predictive models. And he does that in a very compelling and neat way. So the article is called Statistical Modeling: The Two Cultures by Leo Breiman. It was published in Statistical Science in 2001. I found it like the best read to really get some groundings in data science.
Wow, wonderful. Definitely, I haven't heard of that article, but definitely will check it out. Sounds like a great read. And so that's by Leo Breiman. We'll definitely include that in the show notes. Next question I would have is if you could share with us any of the recent data science wins that you've had in your department at Udemy.
Two of them come to mind. My team has been responsible for building the new spam filter on Udemy. So that's the filter that determines whether a review is trustworthy or not. And the old spam filter was built on a set of rules. So it was not even a naive base. It was just a set of rules that totally made sense at the time. But over time, people learn how to circumvert the rules. They'd learned like the logic of the filter, and there was a lot of non-trustworthy or spammy content on Udemy. And so my team tackled this problem, and we were able to improve the accuracy of the spam filter by 8x factor. So it was a big win for the team, but more so for the company as a whole. That was one of them. The second one that comes to mind is more of an ad hoc analysis that we did a couple of weeks ago. So you're an instructor on Udemy, so you know that we changed the pricing strategy, and so there was a resulting change in student behavior. And my team looked at a final price, list price, discount, all of this influenced student decision. information and whether we could build a model that predict how a student would react to different pricing strategies. And so it was a very simple model, and by any means nothing really sophisticated or complex, but it had the ability to explain a lot of the data that we had observed in the past. And so for that reason, it was powerful, both because it had great explanatory power, but also because it was relatively simple and people could understand what it meant.
That's very cool. The 8x accuracy spam filter, that's a significant improvement, and a model for behavior, different content. That's also very interesting. As you say, I'm an instructor on Udemy, and I can't see the back end of these things and how they run in the background, but I can definitely see how changes come into play and how the platform is growing. So it's very exciting to know that you're behind all of those changes. That's really cool. What's your favorite thing about being a data scientist? What's the one thing that excites you to get up and go to work in the morning? One thing that excites you to do your work? And what is that thing that drives you to keep going?
I think the most exciting thing is the intellectual challenge. It's the fact that you are always facing new and unsolved problems, and you're the person who are being asked to solve those problems. And sometimes it's just a data problem, but sometimes it's more complicated than that. Sometimes it's you have to structure the problem and come up with the right data questions, solve them, and give an answer. So that constant intellectual challenge is really what drives me.
And for our listeners, from your perspective, from what you've seen and what you see currently in the field of data science and how you've seen it evolve since you've joined the ranks, where do you think this field is going? What do you think our listeners should prepare for in the future? What should they focus on? What skills should they develop? Or what techniques should they think about? Or generally, where do you think this whole field is going?
Yeah, that's a good question. It's hard to really predict where this is going and to have like a generalized view. I can mention a few trends, and I can mention also like a few areas where I think people can really make a difference and show like and add value. So in general, right now, there's a lot of talks around data platform. So it's not just that you have a data infrastructure, you're mining the data and you're building some models or some insights, but there's also this idea that in order to operate a efficient data team and an efficient analytics team, you need to have platforms that enable data scientists to deploy experiments, run experiments, quickly build and validate models. So there's that aspect of building the pipelines and the workflows that enable people to scale basically analytics. So that's one direction where things are going. And obviously, this also goes into the direction of a little bit more specialization. It used to be that you had this engineer that could build a database, but could also extract data and run some statistical analysis and show the results to the head of marketing. And now more and more you're seeing roles being a little bit more specialized. Now you have people who specialize into data warehouse and data infrastructure, and you have people who are specialized in data platforms, people who specialize into algorithms, people who specialize into more the analytics part of data science. And so I think it's important to understand all of these roles, and there's definitely that's definitely some of the trend in the industry. In parallel, I think what I would recommend is I think it's very important for people to develop deep technological expertise, because that has a lot of value. If you're able to code in Python or R and maybe even throw in a little bit of Java, and you understand all those technologies, it's extremely powerful. But at the same time, I would warn people against becoming too attached to certain statistical techniques or certain machine learning techniques. There's always going to be people who are like specialized in deep learning and recurrent neural nets, and unless you're one of those people, you don't really need to go in that direction, and you also don't necessarily need to learn all the different algorithms. I think it's more important to understand what are the different techniques doing, and really deeply have a deep understanding of statistics and how you use different things in different cases, and have the ability to learn and then apply the right model or the right technique to the right problem. So it's more important to be able to map out the right technique to the right problem rather than know every possible techniques and algorithms that exist under the sun.
Very, very powerful advice there. I'll sum it up for our listeners and just for myself as well. You are observing a trend that data science is becoming kind of more mature as a type of industry, type of work, and therefore some roles are becoming more specialized. So I guess it's a good idea for analysts and aspiring data scientists to start to look out for what they're most interested in, so that eventually they end up doing something that they're passionate about in this field. And also that developing a deep technological expertise in a broad range of tools and techniques is very important, because you don't want to get stuck just using that one technique, because this field is constantly evolving and you want to be able to adapt and learn new skills on the fly, as they say. I think that's some very powerful advice. And I know you've recommended already a great article by the sounds of it from the creator of the Random Forest. Is there any book, one book that you could recommend to our listeners that if they had the time to pick something up and improve their data science careers and skills, what would be the one book that you think they should read?
That's a good question, because I never actually learned data science from a book. I learned it in school. I learned it by doing, or by looking up websites and forums. However, there was one book that sort of influenced my thinking around data analysis, and really cemented my ideas around causation, correlation, how you can torture data to say certain things, and how that thing might be wrong, and how you can look at the same data set and come up with two conclusions. And that book is actually Signal in the Noise by Nate Silver. It is a popular book. It is a book that is not necessarily very technical, but I think the ideas in that book are extremely powerful. And again, it's this idea that data science is not just a set of techniques and tools. It's also a way to think about a problem. And if you don't think correctly about a problem, it doesn't matter that you have the techniques. You're gonna end up with wrong insights and conclusion. And it's more important to have a deep understanding of what you're trying to achieve, how do you approach a problem, how to look at data correctly, and then use the right techniques and tools. So for that reason, I would recommend The Signal and the Noise by Nate Silver.
Lovely. Haven't read that book myself. It's definitely going on my list of books that I'm picking up in the near future. Signal in the Noise by Nate Silver. That has been a pleasure, Ruben. Just for our listeners, where can they find you? How can they contact you, follow you? Any social media, any websites? Where can they get in touch with you?
I think the easiest is to get in touch with me on LinkedIn. I'm working on a blog and a website. It's not up there yet. The link will definitely be on my LinkedIn profile. So that's probably the best way.
Definitely. And we'll also include the link in the show notes as well. If there's going to be any updates, we'll include those as well there. Thank you very much, Ruben. I really appreciate you coming on the show and sharing your insights. I think this has been a wonderful, insightful conversation. Thank you so much for coming along.
Yeah, it was my pleasure. Thanks for inviting me.
So there you go, guys. That was Ruben Kogel. I hope you enjoyed the show. You can get the show notes at www.superdatascience.com/1. So just the number 1. There you can also leave me or Ruben a comment in the comment section at the very bottom. Ask a question or tell us what you thought. Also, if you did enjoy the show, make sure to share it with your friends and work colleagues so that you can help spread the word about the Super Data Science podcast. And I look forward to seeing you next time. Until then, happy analyzing.